Here we go. We're going to define, well, we're not going to. You're going to define a midpoint today. We're going to learn a little bit about the distance formula. And I know you know the distance formula. At least I know you've used it in the past. But we're going to go a little bit more in depth. Again, that difference between 3rd or 4th grade geometry, where we talk about pretty shapes, versus high school level geometry, where we start getting more in depth and talking about points having 0 size and that kind of stuff. And then we're going to revisit Pythagorean Theorem with a little bit of a twist on it. I think you all know what Pythagorean Theorem is, but again, we're going to look at it in a different way. Okay. So, what is a midpoint? Would you like a picture? This is the audience participation part of the program. Would you like a picture? Yes. There we go. There's a picture. M is the midpoint of PQ. Logan, what's a midpoint? Center between 2 points. What do we think, kids? Say again? Ooh. On line segment? What does it mean to be the center? You don't have to raise your hand, I'm talking to you.
Have an equal distance between both points.
Oh, that's a new element. Okay. Hold on, that's a different, yes, but we'll come back to you in a second. Okay, so back to you. M is the midpoint of PQ if
the distance between P and M is equal to the distance of M and Q.
Beautiful. Got that? Okay, now here's the hard part. That defines a midpoint for that particular segment. Here's the big challenge, Logan. Can you generalize that for all midpoints? A point is a midpoint of a segment if
the a midpoint, a point on a line segment is a midpoint if it is of equal distance to both ends of the line segment.
also known as endpoints. Beautiful. Everybody got that? Well done. Let's first give it up for that one. That was well done. Good start right out of the chute. Could you say it again, please? Because I know a lot of people didn't get it. This will be the fun part.
A point is only a midpoint if it is of equal distance to both endpoints on a line segment.
Love it. Now, there's an important element in here that he managed to work into it as per Katya's help, and that is it has to be on the line segment. Why is that important? Well, if I take this point up here and call that point R, that point can also be equidistant from the endpoints of the segment. And we don't want that. R is not a midpoint. That's something different that we'll get to later. So it has to be on the line segment, equidistant. By the way, in geometry or in math, we can take the two words equal and distance and we combine them into one word, equidistant. I don't know why, but just if you're feeling fancies in your panties and you want to use that word, knock yourself out. Okay. Well done, Logan. That's a good start. So now you see what I mean about writing definitions. You need it one more time?
No, I actually, never mind. I remembered what I was going to have a question about.
What was your question going to be? Maybe it'll help somebody else.
No, it was just about the rest of the definition. Or I just, no, it's whatever.
Just click and move on. Okay. All right. Now, before I show you that big scary paragraph, are we all good with the definition of a midpoint?
Yeah.
Okay. Any problems? Okay. Now, one thing I wanted to talk about before we move on is the difference between a midpoint and being between. So if I take this segment PQ, how many points are between P and Q? Say it loud. Infinity. Everybody good with that? Right? I can go up to that and put a point anywhere on that green line segment, and it would be between Gesundheit. However, how many midpoints does a segment have? Only one. Okay, we're going to make a distinction between that because the problems that we're going to work on algebraically today are going to be similar to yesterday, but different because of the fact that there's only one midpoint. Okay. Now, your exposure to midpoint is, I'm guessing, from algebra, you might remember the midpoint formula, yes? So that's what this paragraph, please don't write this whole paragraph down. Okay, read the paragraph, I'll wait. Let me know if you need help with any big words. Sorry. I wouldn't, because I'm going to give you something. Trust me on this one. I'm going to click a couple more and you'll be happy as can be. Leah, how do you find an average between two numbers?
You add them and then divide it by 2.
Bingo. Okay. Add and divide by 2. So, since M is the midpoint of PQ, if I want to find a midpoint between any 2 points, okay, so again, this is the next step of elevating our geometry / algebra to something that's more conducive to an honors class or to a high school level, is we don't just do 1,000 examples with numbers, now we start talking in generalities. I've got some random point, x1, y1, and we call that A. And then we've got some other random point, x2, y2, that we call B. They can be anywhere on a coordinate plane. Okay, Leah, back to you. If I want to take the average of the x coordinates based on A and B, what would I get?
At the average of the x coordinates.
Yep.
When you add x, x1, and x2.
Good. x1 plus x2.
And you divide that by 2.
Bingo. If I want the average of the y coordinates, just to make sure you are with me on this, what would I get?
y1 plus y2 over 2.
Beautiful. Okay. There's the midpoint formula. You've used that before. Now, you may not have used it in this context. And again, some of you are just going to go home and memorize this formula. It's important that you understand what you're doing. As I was grading your midterms, and I'm just about done with them, I'll have them done by probably later today, I was finding a lot of you have no idea what you were doing. You can do it, you just don't know what you're doing. So when it becomes a question of asking you what you're doing, you can't answer that, but you can do it. Okay, that'll make more sense as we carry on. Okay, questions on this? You've seen this before, right? Finding the midpoint on a chord? No? You've never, oh, wow. You went through an entire year of algebra and never calculated a midpoint?
No.
Holy guacamole. Okay, then I'll assume that you haven't seen this before and we'll move forward. Okay, take the average. So let's try it. Here's my recommendation. With a lot of these problems, draw a picture first. It's going to seem silly, but draw a picture, especially if you're a quote-unquote visual learner. There's really no such thing, but we'll go with it. Draw a picture, label your points, calculate the location of M as in mongoose. And don't be bashful, get out your calculators. Some of you continue to make math mistakes because either you don't want, you're afraid to use your calculator, you don't want to use your calculator, whatever. Don't be bashful. I want the right answer. I don't care if you have to use your calculator for it.
Yes.
Also, for now, we want fractions, not decimals.
Wait, you went up yesterday, the other day, didn't you? You haven't been up to the board yet? Okay, go. Oh, sorry.
Do I have to
I mean, it might be helpful to everybody here that got lost. Remember, when you're writing on the board, don't lay your hand on the board, just the pen. I picked a color for you. If you don't like that color, you can change it. Off to a great start.
Oh boy, what'd you do? Holy smokes. Just click on the slide somewhere. Let's not do that again. Yes, sorry, she was breaking my board. I don't know, let's wait and see. You can check with her. She's pretty smart. Jackson? Yes? How'd you do? Yes? Excellent, let's give it up then. That on the front of the board for me. Thank you, beautiful. Now I'm gonna get nitpicky here. Are these supposed to be capital M's? Yes, they are, good. Okay. Because remember, capital M's represent the location of a point. What does lowercase m stand for? Slow, right. And then just to get even more nitpickier, we're going to do this and get rid of the equal sign. Okay, actually, let's rewrite this. And so this would be m. There we go. Okay. The point, parentheses, the location. Okay, just like, so it matches the format up here. Okay? Any problems? Brandon?
Should we leave it as an improper fraction?
Yes, sir. No proper fractions for us ever. Okay. We good? No? As in you're still writing? I'm not going to change it. I'm just going to leave that up, but I'm going to move on. Leah, how old are you?
14.
Okay, let's suppose the average of your age and my age is 40. Can you calculate how old I am? It's a yes/no question. I'm not asking what the answer is. Could you? For the rest of you, you said 14, right? Okay. Calculate how old I am, please. By the way, I didn't do the math. It might be wrong, but that's okay. old am I? Say it loud, say it proud. How'd you get that? Leah?
So I set up the problem, x plus 14 divided by 2.
Hold on. X plus 14 divided by 2 equals 40.
And then to get x by itself, I multiplied by 2 over 1 and I got 8 equals 80, and then I subtract 14 and got 6.
Beautiful. Okay. Good. I'm not 66, by the way. I'm younger than that. Okay. So we can work that backwards, right? Yes?
Yeah.
So why did I have you do this problem about my age? Because our next example is going to change the problem, and I'm going to give you the midpoint and one of the endpoints and have you calculate the other endpoint. Okay, so let me clear this screen. Let me get rid of all this stuff. Should I leave this up here for reference? No? Okay, good. You snoozy, you losey. Okay. Get rid of that. Come here. Put that back. Grab my clicker. Shh. Okay. Again, start with a picture. Do some calculations. I gave you the midpoint. I gave you one of the endpoints. Figure out where the other endpoint is. By the way, what's the label of the other endpoint?
L.
L. Good, as in llama. Pregunta? Yes, this is the one with the number 2 next to it. Not even subtle about it, are you? Are you looking at me like that? You wanna fight? Sure. Okay, you can go. We'll do it always when you have a deal. TikTok. Your son. Go to your happy place and try something. Hold on 1 second. She had a different answer. That doesn't mean you're wrong. One of you is wrong. Or you're both wrong. But you both can't be right. No, you don't miss negativity. You got a lot of nothing. You got some numbers which. Hold on, let me check with my heart rate. Oh, same. You got it now? Ooh, okay, so now, talking to my two groups over here, we've got two different ways to solve this problem. That's interesting, especially since some of you haven't done anything. Drawn a pretty picture, though. What do you got? Why do you raise that? What do you got? Loose? Got a pretty picture. I like the colors. What do you got? Okay. Freya, what color do you want?
Blue.
You gonna stay with blue? All right, come on. Method number 1. And by the way, neither method is more correct, or it's just a matter of how your brain works. Remember, you can only touch the board with the pen. You gotta kind of.
my bad.
There you go. Mm-hmm.
Okay.
You can bring your notes up if you
Okay,
want.
thank you.
Okay, go. Okay, so Freya used the same technique that Leah used in the age problem by setting up two equations. If you call the point L x, y, because it's some random point, then she set up two equations. To find the average of the 2 points, you would take 1 plus x divided by 2, and that has to equal the x value of the midpoint. So you get 1 plus x over 2 equals 5. Then she's got another one up there. Okay, beautiful. You can sit down. Stick the pen on the front. No, nope. To the left. Nope. See a little. Nope. The left. The other left. Keep going. Keep going right there. Yep. Bingo. The other equation would then be the x-coordinate of one endpoint, the x-coordinate of the other endpoint divided by 2. So 2 plus y divided by 2 equals -6, the y value. Solve both of those, you get 9, -14. Questions on that technique? Okay. Yes? Okay, so it's a little confusing because she solved it at the same time that she set up the equation. This is the equation. Okay, why this 2 is here is because actually what she did is this. Multiply both sides by 2. So this canceled. Okay, all right. All right, any problems on this? Okay, so Jackson has a different way. Oh wait, question, Riley? Different way? Just waving your hand in the air? Did you have a different question?
Yeah, I forgot it.
Okay, I'm sorry. I'm just going to move on. Jackson, what do you got? Oh, I know. You got the same answer. Tell us how you did it.
So I found like the difference between the the point K and M, and it was 4, -8.
Okay, so we'll use orange for the x value. So he noticed that when you go from 1 to 5, he added 4. So then what?
The point would have been like 4, -8. No, like from K to M, it's 4, -8. Like the rise over run.
Oh, then you're doing a different technique. Okay, go ahead.
So like I got
Wait, hold on. Before I confuse everybody, hold your technique for 1 second. I'll show you this other technique. I thought you were using this method. This method goes, what do you have to do to go from 1 to 5? You add 4. If I add 4 to this, then going from 5 plus 4 gives me 9. Purple. What do I do to go from 2 to -6? I subtract 8. So -6 minus 8 gives me 14. Okay, so what did you do?
So I found the rise over one was 4, -8. So then I did that to like the M to L, and I got 9, negative 14.
So you use slope.
Yeah.
Beautiful. Okay, so there's 3 techniques now. In case you missed that, Jackson said he calculated the slope between these 2 points and used that same slope to find the location of L. We've done those problems before in the algebra unit. Any one of those 3 techniques will get you 9, negative 14. Do you need to use all 3 of them? No. Do you need to know all 3 of them? No. You need to know one that makes sense to you, one that you understand. Okay? Most people, I will tell you from experience, go with the second technique, where you're just figuring out the difference between each of the coordinates. You can also use the algebra technique, and you can use the slope technique. So your technique is kind of a combination of the 2. Good? Excellent. Now we incorporate some algebra into it. And this is the example that I talked about that's a little bit different than what we did on Monday, but similar to what we did on Monday. So again, start with a picture, label the stuff you know, set up an equation, solve it, and answer the question.
Oh, yellow is horrible.
How do I label the endpoints? P and R, and where's the midpoint? O, okay. OR, 6 minus 3x. PR is 14x. I'm going to talk while you're working. We can solve this problem the same way we solved the problems from Monday if we do a little bit of work on the front end. The first question I have for you is, how long algebraically is PO? Because our ultimate answer is, how long is PO numerically, meaning is it 7, 3, 14, whatever. But how long is PO? Right. 6 minus 3x, yeah. Yeah. So Riley came up with the key piece of information. This is 6 minus 3x. Why, Riley? Perfect. Okay. Now, given that, based on what we did on Monday, Danny, what's my equation? Say what? Well, we got to find x first. What's my equation to solve for x?
Well, I guess you could add 6 minus 3x by itself.
Uh-huh.
And then equal that to 14x plus 2.
Perfect. Minus 2, isn't it? Oh, no, it is plus 2. Sorry. Plus 2. Beautiful. Solve for x, you get your answer, you move on, everything's great. Method number 1. What's x, by the way, just to make sure we're all on the same page? Anybody get it? This is awkward. Tasha, you have it? What's x? 1/2. Yeah? Okay, somebody confirm? Michael, you're shaking your head, yes? Okay, I'll trust the 2 of you. At this stage, we should not have any problem solving a linear equation. But I'm going to change colors to red. I'm going to get rid of this thing that Riley told us about. and try to come up with a different equation. What's the relationship between the segment PR and the segment OR? Who's talking? Jackson. It's half. So if I know that, what equation could I set up? General equation. If you know that OR is half of PR, what algebraic equation could I set up? Anybody else? Based on that information? No? Well, you said, what's half of this? Good. If I take half of this, what should it equal? It already does, but what else should it equal?
Other side.
Danny?
6 minus 3x.
Good. I take the big stick, I snap it in half. The half that I have left has to equal the other half. Okay, that's method number 2. Method number 3. Stay away from the yellow. Jackson already told us that OR is half of PR. What if we flip that? How does OR relate to PR? In other words, I don't like fractions, so I'm not going to use this because fractions icky. What I can do, however, is instead of taking the big stick and cutting it in half, I can take the small stick and multiply by 2. All of those are the exact same thing. They're all going to give you the right answer of x being 1/2. If that's the right answer. I got 2 people answered, but I got 3 people confirming that it's 1/2. 4, a bunch. Okay, I got a bunch of people show. Okay, beautiful. We're going to go with 1/2 then. Does that answer the question? No. The question is, what is PO? Okay. I don't have a value for PO. Well, I do now because Riley told us at the beginning. There's a reason why I asked you for the length of PO, because I want you to recognize the fact that PO is equal to OR. So what I would do is come over here and do 6 minus 3 times 1/2. And that's 3 halves from 6 is 9 halves. And there's my value. If that's 9 halves, that must also be 9 halves. This problem and the last problem, I gave you 3 different methods to solve it. I'm not trying to confuse you. I'm trying to give you more and more weapons for your solving arsenal here. And hoping that one of those clicks in your brain and makes sense. Okay? So do you see the short segment being half of the big segment? Do you see the big segment being twice as big as the small segment? Or do you see the 2 halves of the stick being equal to each other and then have to add up to be the large segment? So notice if you use Riley's technique from the very beginning, it's the exact same problem we did on Monday, except the 2 parts happen to be equal. Because remember on Monday we took the little part plus the little part equals the big part. I don't care which one you want to use because they'll all give you the same answer. Okay? We good? Questions so far? All right, so you see how we're going to continue to incorporate algebra into these problems. Oh, look, there's all the work. Well, I got 1/2 too. I gave you decimal answers. What's a bisector? Bi means 2. Good. What does sect mean? Logan?
Where 2 points meet, or where 2 points meet?
No. That's an intersection. What does the prefix sect mean, or sector? I wouldn't really expect you to know this, but I thought I'd ask anyways. Bi does mean 2. Sect means to cut. So a bisector, cut it into two. What would a trisector do? Cut it into three. Okay. So here, let me just show you the picture. Here's a lot of different ways that you can bisect a segment. Carly, does it make any sense to bisect a line? Why not? Good. Yeah. Lines go on forever. You can't cut something that has no size or an infinite length in half. A segment, however, can be bisected. So in the first picture on the left, I bisected the segment with a point. Okay, so A would be the midpoint of that bisector. In the middle picture, I bisected that segment with a line. I'm using the line to slice the segment in half. And then I was feeling all fancies in my panties, and in the third picture on the right, I bisected the segment with an entire plane. They all do the same thing. They chop that segment in half. So it combines the idea of a midpoint with slicing into two equal parts. Okey doke. I'm not going anywhere. Big one's up. A is the midpoint, which sometimes can also be the bisector, because notice in this picture, not only is it the midpoint, it's also the thing that's chopping it in half. In the middle picture, the orange line is what's doing the slicing, and it finds the midpoint for you. The same thing is true in the far picture to the right. The plane is doing the slicing, but again, finding the midpoint.
So for the plane, the bisector, like which is A, would it be like the same if we're saying like the point like intersects that point A in the plane?
The plane intersects the segment at the point A, yes. Which you'll recall from Monday, that's called the foot. Okay. Now let's do some distance formula. This will be fun. We just took a midterm on this. I threw this in here for practice, but do we need to? We're good on this, right? Yeah? Yeah? 6 squared roots of 2? Yeah, 2 squared roots of 5? 3 squared roots of 10? We're good here, right? Beautiful. I lied. We'll do Pythagorean Theorem first. We haven't talked about this yet, have we? No? So it should be reviewed, because please tell me you did Pythagorean Theorem last year. Oh, okay. What is the Pythagorean Theorem, Luke? Excellent. Actually, that's the Pythagorean Theorem. But you ask any schlub in the street, I don't know why you would do this, but if you stop somebody in the street or somebody in the hallway and say, what's the Pythagorean Theorem? They're going to say exactly what Luke said. A squared plus b squared equals c squared. The paragraph above, however, is the true Pythagorean theorem. Because what if I move A, B, and C into different locations? But again, you still know what it means. Take the two short legs, square them each, add them together, they equal the square of the hypotenuse. Okay, hold on a second. We've got those two red words we haven't really talked about, well, the 3 red words, but the 2 red phrases. Abby, what's a right triangle?
Like a triangle that like has like an equal square.
What is, okay, so what is,
angle.
oh, say again?
90-degree angle.
Right, so that square means there's a 90-degree angle, also known as a corner. We'll delve more into that later, but for now, yeah, it's got the box in the corner, which means it works. Okay, good. Abby, what's a hypotenuse?
I don't remember.
Ooh. Do you know which side is the hypotenuse?
The long one.
A, B, or C?
C.
C. C is the hypotenuse. You still haven't defined it, though. No? Jackson, you know a definition for a hypotenuse?
Oh, the line that makes a 90-degree angle.
Okay, careful. Be careful with your vocabulary. You want to start over there?
I thought that was fine.
You use the word line. Those aren't lines. What are those?
I'm like the line that connects the 90-degree angle into a triangle.
They're not lines.
Yes.
They're not?
So the legs.
Oh, which ones are the legs? A and B are the legs, yes. But you still haven't answered the question, what's a hypotenuse? Well, what is it? I mean, I can point to a dog, but that doesn't tell me what a dog is. That's a computer. What's a computer? Lucy? Bingo! Number 1. Hypotenuse is the longest side. Longest, spell Reedy. Longest side. Number 2, how do I find it easily? How do I know that C is the longest side? It's opposite the right angle. Opposite the right angle. Angle, not angel. Spell it correctly. Big difference. Okay. I know you've done this before, so we're just going to dive right into it. Here we go. Solve that. And again, don't be bashful about picking up your calculators. Nobody cares if you're using your calculator. You care if you get it wrong. Quick question before you go down the rabbit hole. In problem number 1, are we solving for A, B, or C? C. Beautiful. Keep going. Hi, Slappy. What did we get for an answer? So you're just going to draw a train? Okay. This is awkward for everyone. Just going to walk away. Hopefully it'll make sense when we come back around. Is that good? How was it?
I know this one.
Oh, you're going to say. Decimal? Yeah, for these. I don't know. What did you get, Danny? What did you get?
It's not even
How did
funny.
I want 60? Is that 5? That must be 2,000 something.
I know this 2 years ago, but this.
Yeah, I just do a squared plus b squared because c squared, so it's
I remember.
5 squared plus 12
So you're over.
equals c squared.
All right, 13, yes?
Yeah.
All right, so sidebar. By the way, a sidebar is when I divert from what we're talking about to give you some other information. When you solve a Pythagorean theorem problem and you get 3 pretty answers, so notice 5 is a pretty number, 12 is a pretty number, and when you do all the math, you get another pretty number. That's commonly called the Pythagorean triple. 5, 12, 13 is one of the Pythagorean triples. Another common Pythagorean triple is 3, 4, 5. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, which is 5 squared. Ava has a question.
Yeah, wait, I just got 13, but would it be closer to 16?
No. Now, great question though. So, did everybody hear Ava's question? What we were doing before when we were solving equations is we're looking for a value. The difference here is that it's tied to a geometry thing. Right? It's the length of a triangle, and what I mentioned on Monday, no negative distances anymore. So technically, if I ask you what's the square root of 169,
If you're solving an algebraic problem, it would be plus or minus 13. But here, we're dealing with distances of just the positive things.
Okay.
Okay? All right, so we're good, yeah, so far? That's a Pythagorean triple. We get a nice, pretty answer of 13. So you know where this is going, right? Let's look at a non-pretty answer. Read the problem. Don't automatically think that the two sides I gave you are A and B. I'm actually looking for the shortest side. Whether you want to call that A or B, it doesn't matter. How long is the hypotenuse in this problem? Let's see. 25, correct. Work smarter, not harder. You know what I'm saying? That's not a pretty answer. No. So what are you gonna do now? You like that? Okay, I like that idea. Or just take a dozen. Big ugly answer like that, I'd be okay with it. Not a pretty answer, yes?
Yes.
So you could try to simplify. By the way, are we all at the same page here? Square root of 429?
Yeah.
We're good on that? No? Okay, let's back up here. A squared plus 14 squared equals 25 squared. Remember, we're solving for the shortest side. The hypotenuse is always by itself over on the other side. A squared plus 196 is equal to 625. So A squared is equal to 429. So A is equal to the square root of 429.
We said B is on line.
Yeah.
Yeah, it doesn't matter. Yeah, A or B, as long as it's one of the shorter legs and not the hypotenuse. All right, how do you, yeah.
I put A squared plus C squared. Like, for like the one, I did A squared plus C squared. And now I-
What's important is where did you put the numbers? Are you solving for A or B?
I'm sorry.
Okay, as long as it's one of the numbers on this side, you're okay.
I did like 14 squared plus 25 squared. No?
Because that would be if you're solving for the hypotenuse. Remember, this side of the equation, in this formula, A squared plus B squared equals C squared, this has to always be the hypotenuse or the longest side. No exceptions. Okay, so my point is, what do we do with that answer? You could try to simplify that, like what goes into that that's a perfect square. Leave it alone, that's option one. That's kind of a pain in the butt. Option two, leave it alone and leave that as your answer. By the way, that would be an exact answer. Or option three, Ryan, plug it into your calculator and give me a decimal value of?
20.71.
Love it. We know what that symbol means, right? This symbol? The double tilde means what, Lily? No. Equal means exact. It means about. Close to. Approximately equal to.
What was the one with the equal?
Oh, great question. This one? Same shape, same size. congruent, correct. Your iPads are all congruent. You and I are not congruent. Right? Who's the tiniest? Luke, maybe? Luke and I are not congruent. Right. Problems? We're good? So some people told me they've never seen this before. Let's take a quick survey. How many of you have done Pythagorean Theorem? All right, that's too easy. Put your hands down. Who hasn't? Say it loud, say it proud. Put your hands up. Come
I
on.
did it in 8th grade.
8th grade, so you've seen it, but that was a long time ago. That was at least, what, 2 years ago, right? Okay.
I have a question.
Certainly.
It's find the shortest side, right? But isn't 14 the shortest side?
Ooh. So what are you saying?
Am I just wrong? Or, like, did you miswrite the problem?
I miswrote the problem.
Oh,
Yeah, because it turns out to not be, unless Ryan doesn't know how to work his calculator, we blame him. That's what we'll go with. We'll go with it's Ryan's fault. Jeez, dude, come on, you're killing me. Problem fixed. Well, it's not the shortest. We could go shorter or shortish. Or short-like, hyphenated. Okay, problems? Beautiful. Moving on. What do we got next? Oh, the distance formula. Just for giggles, can anybody fire off the distance formula from memory? Because I know some of you are memorizers. Logan, you think so? Give it a shot.
X1 plus X2 divided by 2, comma, Y1 plus Y2 divided by 2.
That's excellent, except that's the midpoint formula. We want distance formula. Yeah. How far is it between 2 points on a coordinate plane? Anybody else? Lucas?
So, let's use it. X1 minus X2 plus Y1 minus Y2.
So close. Danny? Getting warmer. Anybody else? Okay. It's all right if you don't know. You're going to learn right now. So I'm guessing you've done distance formula, and I'm guessing at the time your teacher just gave you a formula, which is what everybody's trying to remember, and then you went. You got it? Not even close.
Like the distance equals velocity.
Oh. We call that the dirt equation. Distance equals rate times time, dirt. Yeah, that's something different. We'll get to that later. Okay, so let's start with a coordinate plane, named after a guy named Cartesian, or Cartier was his name. René Descartes. Who cares? Let's move on. I put 2 random points on that screen. Now, don't think that because it's on a coordinate plane, you can tell me, oh, x2, y2 is at about 2, 3. No, they're just random points. They can be anywhere. I just put them on a coordinate plane so that you know what we're doing. We're finding the distance between 2 random points on a coordinate plane. I want to know that distance. Okay? So again, staying with the theme of today, I'm going to give you multiple ways to do it. There's one way that I like to do it over the other, but again, I want to give you some options. One method, which I don't like, is memorizing. So what's going to happen is some of you are going to tune me out for the next couple of minutes, and then you're just going to write down the formula at the bottom. You're going to try to memorize it, and you're going to miss something and screw it up. So I'm going to show you a different technique that doesn't require memorization, but it does require understanding. Ooh, this will be fun. Okay. My method involves being able to answer one simple question, and that is, if I put a vertical segment in there, that red segment, how long is that red segment? Now, what some of you are going to say is you're going to go 7, because it's 7 squares. And I'm going to say no, because those points can be anywhere. So if I know that one point is at x1, y1, and the other point is at x2, y2, I'll ask again, how long is that red segment? Oh, but you will. Okay, so let's try this. Since that's stumping you, let me ask a different question. If I put this point, I need some working room here. We'll go here. And this point, 1, 2, 3, 4, 5, 6, 7, 8, 9. Where'd my point go? Okay, so this is at negative 9, comma, 1, 2, 3, 4, 5, 6, 7, 9. And this is at negative 9, 3. How long is that segment? Yes. 6. Beautiful. Now, how did you get that? Did you count or did you do some math? Excellent. Okay, everybody good with 6? Yeah. Okay, good. Danny, back to you. How long is that red segment? Outstanding. Okay, now this is crucial for making sure you can do the distance formula. I don't want to move on until you understand. Actually, mine's reversed, but it's okay. It's the same thing. Does everybody understand why that red segment is y1 minus y2? Speak now or forever hold your peace. If not, I can go over it again. That's okay, but I need you to be sure you understand this and not be bashful about, I'm the only one who doesn't understand why that's y2, y1 minus y2, and I don't want to ask because it'll be embarrassing, and then I have to go see my counselor. Right. Beautiful. Okay, so that's a vertical segment, right? Riley?
What?
It's a vertical segment.
Yeah.
Notice that the x-coordinate here is the same as the x-coordinate down at the bottom. So that's not going to help us. Right? The length of that red segment is the difference between the y segments. Okay, so you and I start walking here.
Oh, okay.
You got it?
Yeah.
Okay, good. Then I won't give you my analogy. Everybody else good to go? Okay, now, if you understand what's going on, then I ask this question. How long is the blue segment? Leah?
X1 minus X2.
Bingo. Okay? For the same reason. Y coordinates are the same. The length of that blue segment is the difference between the x coordinates. And by the way, it doesn't matter if you do x1 minus x2 or x2 minus x1 as long as you stay consistent. Now, this is the way I like to do the distance formula. I create a right triangle. And then I just do Pythagorean Theorem over and over again. You've already done Pythagorean Theorem. You're pretty good at it. So subtract the y values, get a number. Subtract the x values, get a number. And then do Pythagorean Theorem. Does that make sense? Because notice this is a right triangle now. And I know the two legs, the red segment and the blue segment, are the legs of the right triangle. The distance that we're looking for is the hypotenuse. I'm going to give this to you anyways, because I hesitate to, but you'd find it anyways. That is the distance formula. Where does that come from? It comes from doing Pythagorean Theorem. Take the blue segment and square it. Add it to the red segment squared. But where did the square root come from? Well, let's do some math. If I've got, whoops, try that again. If I've got a squared plus b squared equals c squared, isn't c just equal to the square root of a squared plus b squared? Take the square root of both sides. That's where the distance formula comes from. So again, to rehash, some of you are just going to apply the distance formula. You're going to think you can memorize that, and you might succeed, but there are a lot of spots for errors. You heard when people were trying to regurgitate the distance formula, some people switched the pluses and the minuses. Some people forgot the squared term. Everybody forgot the square root term. There's a lot of margin for error there. Subtracting the x's, subtracting the y's, and doing Pythagorean Theorem, there's not a lot of margin for error there. You can all do subtraction. You can all do Pythagorean Theorem. Pregunta.
So like we kind of just once we find like these two
Yep.
just plug it in there.
100%.
So we don't
Oh, I'm stuttering.
Let me try that again. I'm excited about math, I'm sorry. I wouldn't even recommend the thing in the green box. Forget about it. Okay? But I wanted to give it to you because some people are going to rely on that.
Wait, so the way you could just use this. Like this isn't really.
I got an example. Okay? Let's do this back. So you can write it down if you want. I wouldn't. What?
So
Oh, I got it.
That's not what I would do, but you can. Okay, so hold on. Here's my example. Let me work through this. I'll show you the two different ways to do it, and then we can ask questions. Okay, so in a lovely shade of blue, I would do my method first and take the difference between the x-coordinates. Okay, -3 minus 4 is -7. I'm going to come back to that in a second. -5 minus -6 is 1. Okay, I don't know why that's there. I've got -7 and 1. Those are the lengths of my legs of the right triangle. So now I'm going to go a squared plus b squared equals, instead of c, since I'm doing distance, I'm going to change it to d squared.
How do you have a -7 if you can't have a negative distance?
Ooh, great question. We have to pretend. Because what happens when we square a negative number?
Those positive.
It becomes positive. 49 plus 1 equals distance squared, so d is equal to the square root of 50. I subtracted the y coordinates. Or sorry, the x coordinates. -3 minus 4.
Oh.
Okay. Now, to make matters even more confusing, I'm going to change to red and do it the same way, but do the points in a different order. 4 minus -3 equals 7. -6 minus -5 equals -1. 7 squared plus -1 squared equals d squared. D is equal to, same answer. It doesn't matter which one you consider x1 or y1 as long as you stay consistent. Left minus right, right minus left. I don't care. Okay. Here.
When you put like the -3 minus 4, why should it change?
Just because I was checking that I know what -3 minus 4 is.
Okay.
That's one of my coordinates.
Okay.
Okay, so questions on this technique. All right. Now, let me show you the other tech. Can I erase this, by the way? You're still writing. We're good? Okay. Are you shaking your head no? That was a yes. Yes, you're shaking your head no, or yes?
Yeah.
Yes, you. What? Let's back up. Can I erase this? Okay. That took way longer than expected. Good? Okay. Get rid of this. And again, I don't want to restrict you by telling you what method to use if all these methods will work. So I'll show you what the other one looks like. And some of you might go, hell yeah, I'm doing that method. I like that. That's fine. I don't care. As long as you can get the correct answer. D is equal to the square root of -3 minus 4 quantity squared plus -5 minus -6 quantity squared. -7 squared plus 1 squared, square root of the whole thing. 49 plus 1, square root of the whole thing, square root of 50. Okay, same answer. So some of you might be saying, well, that's easy peasy. And you might be right. But again, I would argue that that distance formula in the green box, there's a lot of spots there that you can screw up on. It's pretty hard to screw up on subtracting two numbers and then applying Pythagorean theorem. Okay? But again, all three methods got me the square root of 50. So I'm happy. It's the same answer.
How we doing? You try this one now. Whatever technique you want to use, go ahead and solve it. When you get done, check with the rest of your group and make sure you're not the odd person out. But even if you are the odd person out, maybe the other three in your group don't have a clue what they're doing. Can I talk while you're working? Okay. You'll notice that this is, again, similar to Monday, this is a fairly long lesson. But I'm also going through this at a pretty casual pace. I don't want to rush through this. I want to give you plenty of time to solve the problems and make sure you're okay. A lot of what's going to happen as we continue is it's going to put a lot of pressure on you to not be bashful, to say, I don't get that. Can you explain it again? Now, whether that happens here in class during the lesson, or if it happens during your lunch period, whatever, but don't think these things are going to go away. Make sure you understand what we're talking about here.
You should never get like
It's so bad.
All the same? Get it?
It's just like a dark line.
Yes? Yep. Good. Yep. Yep. Good. Nice. Okay, good. So the groups that I checked, which is most of you, all got the same answer. Square root of 194, yes? Yes. Okay, now quick survey. Who used the actual distance formula to plug into that green box thing? Raise your hand. And again, don't be bashful. That's okay if you want to do it. But again, some of you made some sign errors in there. I don't want to mention any names. But some of you fell right into the trap of making a mistake with a minus versus a plus. Okay, but again, I don't want to mention any names. I would assume then that the rest of you, raise your hand, use the Pythagorean Theorem technique. Okay, good. Again, it doesn't matter. If you raise your hand for the different distance formula, Logan, I'm assuming you got the square root of 194.
Yes.
Hot diggity. I'm assuming that the rest of you that did the Pythagorean Theorem technique got the square root of 194, yes?
Yes.
Okay, so again, we're ending up at the same spot. I don't care what method you want to use. Alex?
When this is approximate, does that mean that we need to find like the
Excellent, I was going to get to that next. Okay, so you understand my point. Whatever technique you want to use, I don't care. Some of you might even feel a little saucy and bounce back and forth between the two different techniques. Right? I don't care. It's okay. Alex asked a great question. You'll notice in problem number 1 it says the exact distance. What does exact distance mean? That means if you get a square root, you leave the square root in there. Okay. However you simplify it. So remember in problem number 1 I got the square root of 50. The correct answer would be 5 square roots of 2. So simplify your radical and leave it alone. Approximate distance is you punch it into your calculator and get an answer of what, Ryan?
13.93.
13.93. To even everything out between us, let's round the approximate answers to 2 decimal places to start. Okay? Yeah, if you want to show off. Whoops. I just did exactly what I wasn't supposed to do. $13.93?
Yes.
Yeah, there we go. Okay, whereas this distance is equal to 5 square roots of 2. Exact answer, approximate answer. For me, that's not a huge deal breaker. Just try to follow the directions. If I say exact, I'd like you to leave it in square root form. Now, what if your answer turns out to be pretty? Like 14. Is that an exact answer or an approximate answer? It's actually both. Okay? But again, if we get the weird answers that we're not used to working with, then make sure you understand the difference between exact and approximate. Worky doke? Questions? We're done. Okay, so let me talk a little bit again about procedure and stuff. You'll notice it's 11:08. I'm not going to try to rush in the last 12 minutes and start going over some homework. I want to spend some time tomorrow talking about the day 1 homework, and then obviously talking about the day 2 homework. I posted the day 1 answers. I'm going to back things up a little bit and not necessarily post homework answers right away, because I know some of you have become addicted like junkies to the answers. You can't solve a problem unless you check your answer and move on. So for the day 2 homework, I'm not going to post the answers because I just want you to get in there and get your hands dirty. Making mistakes is okay. Today's Wednesday, right?
Yeah.
On Friday, when we come back, we're not going to have a new lesson. We're just going to kind of play catch up for that entire day. Okay, so we'll go over the day 1 homework. Nice and slow to make sure you understand all the problems. Remember, we're talking quality over quantity. Then we'll talk about the day 2 homework, the same idea. Check to make sure you did your distance formulas correct. Make sure you understand correctly. Sorry, bad English. Make sure you understand how the Pythagorean Theorem works. Did you put your variable in the right place? Are you solving for a leg or are you solving for a hypotenuse? Do you understand how to find a midpoint? Do you understand what a midpoint is? That kind of stuff. Okay. Then I'll have an assignment for you on Friday, which will be more review. Our first quiz on this stuff will then be, oh wait, we have Monday. You have Monday off, so that would be, I would normally see you on Tuesday, so it would actually be Wednesday. A week from today will be our first chapter 1 quiz. Okay? I'm sorry, what was that?
No, I'm kidding.
Sound good?
This would just be on like these 2 lessons? Or
First 2 days. Well, first 3 days. The third day isn't anything new.
What is it? What's the quiz?
A week from today.
Oh.
Okay? Any other questions? All right, I'll unlock the day 2 homework. Please use your last 10 minutes wisely. Get started on that in case you have some questions. Gotta stop the lesson.